Now let's move to question 5. Question 5, we have a diagram. Below shows a 3 kilogram block connected to a 1 kilogram block with a light extensible string. A constant horizontal force of that one. Okay, constant horizontal force and constant speed is not the same, okay? Along a rough horizontal surface, so there is friction here, pulling this object, and then also there is friction in this one. Remember, if they are all going up the slope, it means now the friction will oppose the motion. Okay. So, and then they tell you that the friction between P and Q are 2 and 1 respectively. So it means P matches the 2 and then Q matches the 1. So P experiences 2 newtons friction and then this one experiences 1 newton friction. The slope is 30 degrees with the horizontal. State Newton's second law in weight. Remember, it says when a net force is applied to an object, the object accelerates in the direction of the net force. Okay? Or you can say when a net force is applied to an object will accelerate, yes, in the direction of the net force. Okay? And then this acceleration is directly proportional to the net force, 1 Mach, and inversely proportional to the mass, another Mach. Draw a double free body diagram showing all forces acting on 3 kilogram block. Acting where? On this block here. So how can you do that? We can do that here and say, okay, what I like students to do is, we have an inclined like this. So draw like that, those dotted lines, and say, you know that normal force, it is perpendicular to the surface. And then you have Fg always acting downward. And can you see you have your what? You have your 20 newtons, or you can say, let's call it force applied. Let's call it force applied for now. Okay. Force applied, or just F. Just F will be fine. And then remember, we also have what? Frictional force, or let's start with tension. And we also have what? Tension moving there. So I can remove these and say this is my free body diagram. Okay, this is my free body diagram. When they ask you to draw a free body diagram, do not break Fg into its components. We're gonna do that for the purpose of calculations. Let me put it here. I have this, I have that, like that. So this is what you're expected to draw, okay? But for the purpose of calculations, we're gonna break this into its component, okay? This is 5 marks because it is 1 mark, 1 mark, 1 mark, 1 mark, 1 mark. Then for calculations, we're gonna use this one. For calculations, we're gonna use this one. The very same one, but we're gonna now instead break what? We're gonna break this Fg into its components. What do I mean by that? It means I'm gonna have Fg acting downward, which is my Fg perpendicular. And then I'm gonna have my Fg parallel moving downwards like that. And then I can ignore this one. Okay, so for calculations, I have this. Then they say calculate the magnitude of the acceleration on the block, on the 3 kg block, sorry. Okay, on the 3 kg block. So what can I do? What can I do in this case? What I can do, I can say, okay, let me apply F net is equal to MA. Okay, F net, it is equal to MA. Let me apply this for the 3 kilogram block. Okay. All right. So what am I looking for? Calculate the magnitude of the acceleration. All right. Now we have F net, so we're gonna choose up the incline as positive. Up the incline is positive, so we're gonna have friction going up the incline, not friction, applied force, and then you're gonna have minus what all the other forces are acting downward. Okay, so okay, this is not tension again, this is friction. Sorry about that. This is friction, and then you're gonna have minus friction minus Fg parallel minus tension. It is equal to Ma. Okay, and then we'll just have whatever that we have here. And then F, we have force applied to be 20. Remember that force applied, it is 20 here. And then you have Fk of the 3 kilogram block. Remember Fk of 3 kilogram block? I said 3 kilogram block, it is block P. It is what? How much? P, it is 2. Fk, it is 2 minus, remember Fg parallel is the same as mg sine of theta. Okay, so it's gonna be mass 3 multiplied by 9,8 multiplied the sine of the angle, it is 30 degrees. Okay, and then let me see. I want to see something, by the way. P experiences 2, Q experiences 1. Okay, mg sine theta. So okay, and then minus tension, it is equal to 3a. And then you can see that tension, it is unknown in this equation. Again, tension, it is unknown. All right. So let's continue now with our calculations, whatever that I can do. So let's take tension to the other side. When it's gonna be, okay, just punch this on a calculator. When you punch that on a calculator, it's gonna be 20 minus 2, 20 minus 2 minus 3 multiplied by 9,8 multiplied by, don't forget the sign. Don't forget the sign of 30 degrees. And then it's gonna give you something like 3.33. 3.3, sorry, minus t, it is equal to 3a. Therefore, it means t is going to be equal to, when you take this to the other side and then take 3a to the other side, is going to be minus 3a. Okay, then you got the 3.3 on that side, so we're going to leave it like that. So let's say this is my equation 1. And then there's nothing that I can do. I'm going to say let me apply F net, it is equal to Ma on the 1 kg block. On the 1 kg block now, on block Q. Okay, on block Q, what do I have? Sorry, this is not tension and tension. Oh, I fixed that. Let's draw a free body diagram for the 1 kg block. It's going to be the tension in that way. Remember, I said if the tension is this way here, it means for that way, for this object is that way. And then we have the friction. And then we just have our normal force. And then we have our Fg, which will be broken down to Fg perpendicular and Fg parallel. So I can remove this. So now I'm focusing on those that are acting horizontal. So it's going to be tension moving upwards. We still choose this as positive. It's going to be tension moving upwards minus frictional force minus what? Minus Fg parallel is equal to Ma. But still remember, Fg parallel, it is the same as mg sine of theta. So in this case, it's going to be tension minus, remember 1 kg kilogram experience 1 Newton friction. Okay, friction of 1 kilonewtons. Here it is. Okay, and then Fg, it's easy, it is mg. So I'm going to say it is 1 multiplied by 9,8 sine of 30 degrees. It is equal to 1 multiplied by A. And then tension is going to be tension minus -1. Okay, -1 minus 9,8 sine theta, sine 30 in this case. I'm going to have, why is it positive? Okay, let me do this. Shift mode. I wanna make my calculator clear. Yes, you see. Okay. So let's do that again. -1 minus 9,8 sine of 30. Okay. Negative 5.9. It is equal to A. 1 times 8 is A. And then tension here is equal to 5.9. Okay, let me say A plus 5.9. Then this is going to be your equation number 2. And then equate equation number 2 with equation number 1 with equation number 2. So it's going to be what? Negative 3A plus 3.3. It is equal to A plus 5.9. Then negative 3A minus A is minus 4A is equal to 5.9 minus 5.9. Is it negative there? Yes. All right. Let me just confirm this because my calculator was in whatever mode. A times 9,8 sine of theta. Okay, it's fine. All right. And then I have negative 4A is equal to 5.9 minus 3.3. 5.9 minus 3.3. I get 2.6. Okay, I get 2.6. And then my acceleration is going to now be equal to, I don't know why my acceleration is negative, by the way. I'm going to get 2.6 divided by negative 4, which is negative 0.65 meters per second squared. Okay, let us confirm something. If value indeed my acceleration is supposed to be that value. So we said F net is equal to FA, and then we have friction going upwards minus Fk minus Fg parallel minus tension. And then here F20 minus 2 minus 3 times 9,8 sine 30 minus T is equal to 3A, and then 3.3 minus T is equal to that, and then, okay. F net is equal to MA, then we have tension minus Fk minus Fg parallel. Then it's going to be tension minus Fk is 1 minus 1 times 9,8 sine 30 multiplied by 1 times A. And then tension is going to be equal to, let me repeat that again, 9,8 sine 30. It is negative 4.9 minus 1. Yes, it's that. And then I take it to the other side, it becomes positive. And then, okay, everything seems to be fine. And then, will I get acceleration of negative? Okay, will I get a negative acceleration? So this means that if I made a mistake somewhere, please correct it, okay? But the analogy should be the same. Let me just confirm. All right. So remember, they said calculate the magnitude of the acceleration. Therefore, you need to say, therefore, acceleration it is 0.65 meters per second squared. If they wanted acceleration, not the magnitude of acceleration, you are going to say it is 0.65 meters per second squared moving downwards. Okay, moving downwards. And I'm not sure why the answer that we got here is negative. But yeah, it's basically that, by the way. Nothing we can do, unfortunately. All right. So yeah, that's it, guys. It wasn't a bad question at all. It wasn't that bad. Just wanted you to analyze.